CO2 prices will increase over the coming years. This means that an energy system designed for today's CO2 price may not be the best solution in later years. In this video, I show you how you can investigate the influence of different CO2 prices on the optimal energy system using nPro. Hi and welcome to this nPro tutorial. I'm Marco, and in this video I explain to you how you can use nPro to calculate the optimal energy system for different CO2 prices. This allows you to find alternative energy systems that have lower CO2 emissions compared to the cost-optimal system. For this purpose, nPro has a built-in feature to conduct a sensitivity analysis automatically with just a few clicks. Let's have a look at how that works in nPro.
To analyze the CO2 price and the effect on the optimal system, we go to the module Energy Hub. Here we create a new project. Here I choose coupled heat and cold supply for this example. I say create new project, and we can modify the system structure. Here we have a heat demand, a cooling demand, a heat recovery chiller that generates heat and cold at the same time, and an air source heat pump. For the electricity supply, we have a photovoltaic system and a connection to the electricity grid. Of course, we can change the settings of the technologies, for example, the COP. We can upload a COP profile or calculate the COP profile. I just leave the standard settings here. We can upload energy demand profiles. Yeah, I just use the default profiles of nPro. And of course, we can change the economic parameters of the electricity grid, supply price, feed-in tariff, etc. To investigate the CO2 price effect, I go to ecologic parameters. Here we can, in the section CO2 pricing, we can enter a CO2 price, or we can activate the sensitivity analysis. And this means we have here three values, 0, 50 and 180 euro per ton. And we can add new values here. Let's put it 250 euro per ton as well. I say add, and then we have 4 different CO2 prices. And we can now calculate the optimal system for all of these CO2 prices. So I click on OK, and then size technologies. And then we will see how the system changes with changing CO2 price. So the system 1 is a reference system that has a CO2 price of 0 euro per ton. And we can see here on the top that 205 kilowatt peak of photovoltaic is installed. And this capacity increases as we increase the CO2 price. So for a CO2 price of 250 euro per ton, we have a photovoltaic capacity of 469 kilowatt peak. On the right-hand side, we see the heat storage. You can see that the storage capacity also increases with the increasing CO2 price. So we have more flexibility in the system, basically due to the increasing photovoltaic capacity. On the bottom, we have the table with all the results. The system number 1 is the reference system. We see that the total annualized costs are 86,000 euro per year, and we have CO2 emissions of 107 tons per year. And now we can have a look at system number 2 and system number 3 and see how the CO2 emissions decrease while the costs normally increase. So for example, system number 3 looks pretty good because we have a cost increase of only 2%, but we can decrease the CO2 emissions by 27%. So we can select system number 3 and then basically proceed as we would do it in the normal calculation. So now we have the table with the design results. We could also change the results if we want to, and then click on Simulate System Operation to calculate the operation over the entire year.
If you have any questions or remarks about this video, feel free to leave a comment. If the video was helpful for you, please give us a like and subscribe to our channel. Thank you for your interest and see you next time.